In this video, we are going to add and subtract polynomials. So we're going to start with addition. What you see on the screen is you see two polynomials, each encased in parentheses. So you can see here that we have a trinomial plus a trinomial being added together. And hopefully what your gut is already telling you is that when you have parentheses without a number in front of them, you should know that there is really a 1 out here in front of parentheses. And what we can do is, in order to get rid of those parentheses, we can take that 1 and we can distribute it to every item on the inside. Now, I strongly recommend using keep, change, change here so you don't make a mistake with your signs. But if we distribute out that 1, we find that we have 2x cubed plus a negative 5x squared plus, this is really a 1 here, so 1x, plus, in the second parenthesis, we have 2x squared plus 1x cubed plus a negative 1. So what I've done here is I've distributed out those 1's in order to get rid of the parentheses. Then from here, if I think back to what I know about algebra and terms that can be combined together, I know that we can only add together like terms, which means we can only add terms together with identical variable parts. We have to have like terms. So as I go through, I'm going to pick the highest degree because I like to start with the highest and then rewrite it down to the lowest degree. But what I notice here is that cubed is our highest degree. And I notice if I look through all of my terms that there are two terms that contain the x cubed. And because those are identical variable parts, they can be combined together by simply adding their coefficients to be 3x cubed. 2 plus 1 is 3. Then from here I move on, and I notice that there are a number of x squareds. And here when I look carefully, I notice I have a negative 5x squared plus a 2x squared, and negative 5 plus 2 gives me a negative 3x squared. Then from here I move on to look at terms that contain just an x, and I notice that there's only one, so that stays plus 1x. And then I notice that the constants without a variable, I'm left with just a constant of negative 1. Now from here I've written these using keep, change, change. Your other option is you can write those plus negatives as simply subtraction signs. Either one of these options will be correct. So now we're going to move on to subtraction. And remember that as we get to that combining part, we can only add things together that contain like variable parts. So we're going to go through the same process here. I notice that I have a 1 out in front here, as well as a 1 out in front here. And then I'm also going to go through and utilize keep, change, change wherever I can. So here I look, and my first distribution is just distributing a 1, so I have 4x cubed plus a negative 7x squared plus 1x. And then I notice that as a result of using keep, change, change, this second set of parentheses, I'm really distributing a negative 1. So negative 1 times 3x squared is a negative 3x squared. Negative 1 times negative 2x cubed is a negative times a negative, so a positive 2x cubed. And then a negative 1 times negative 8 is a positive 8. So notice how this second set of parentheses has a negative 1 get distributed to it. And as a result, the signs of all three terms actually change to be the opposite of what they were. Now from here, we're going to combine our like variable parts, starting with the highest degree. I notice the highest degree is x cubed. And I notice I have two terms that contain an x cubed for a total of 4 plus 2, or 6 x cubes. I then notice that I have two terms that contain an x squared. Negative 7 plus negative 3 becomes a negative 10 x squared. I then have one term that contains an x, so that stays just 1x. And then I have one term that is a constant, that just stays a constant. Now again from here, if you don't like the plus and negative, you could write that as subtract 10x plus 1x plus 8. either one of these answers will be sufficient.